Welcome to the next installment of my video lecture series for managerial economics. And in this particular video lecture, I'm just going to walk you through taking a derivative as something that you're going to need to do throughout this course. And I want to make sure students understand how to take a derivative. Please note that this is really set up for people who either have never taken a derivative or has been so long since they've taken a derivative that they need a little bit of a refresher. So just realize that this is a very simplistic way of doing it. I'm not going to get into this heavily mathematically. So it's just so that you can mechanically or physically go through and take the derivative of functions as part of this course. So I'm going to start very simply with a very simple function, y is equal to 4. So we have a horizontal line that intersects the y-axis at 4. So let's take a look at the relationship between x and y for this. So when x is equal to 0, y is equal to 4. When x is equal to 1, y is equal to 4. When x is equal to 2, y is still equal to 4. When x is equal to 3, y is equal to 4, and etc. So this does not change. Y is always equal to 4 regardless of what x equals to. So if we're taking a look at how y changes when x changes, it doesn't change. The change in y is always 0. It goes from 4 to 4, 4 to 4, 4 to 4, etc. So the change in y with respect to x is equal to 0. So make sure you remember that. The derivative of a constant is equal to 0. So the first derivative of this function y is equal to 4, the derivative of y with respect to x is equal to 0 because y does not change with respect to x. Let's move this a little higher, and now we have y is equal to 3x plus 4. So now we have a line that has a slope to it. So let's take a look at the relationship between x and y. When x is equal to 0, y is equal to 4. When x is equal to 1, y is equal to 7. When x is equal to 2, y is equal to 10. When x is equal to 3, y is equal to 13, etc. So you can see here when x changes, y changes. So we physically can measure a change in y with respect to x. And what we can see is every time we incrementally increase x by 1, y increases by 3. It goes from 4 to 7, which is an increase of 3, 7 to 10, which is an increase of 3, 10 to 13, which is an increase of 3, and so on. So we know that with the incremental changes in x of 1, y is going to change by 3. So if we work through this, I want you to note that here's the original equation. I have just put 1 in the exponent here just for purposes of illustrating how you physically calculate the derivative. Normally, we have 3x to the first power. The 1 gets dropped off and it looks like this. But for our purposes to illustrate mechanically or physically what you're doing with this when you're taking a derivative, I wrote it in this form here. So if you remember previously, that the first derivative of a constant is equal to 0. So this part of the function here is going to be equal to 0. So all we're really going to be concerned with is taking the first derivative of this first part here, 3x. So when you take the derivative, all you end up doing is taking the number that's in the exponent and multiplying it in front of that function. So we would multiply this entire function by 1 here. And then you subtract 1 off of the exponent, like I have right here. So I took that 1 and multiplied it in the front. I had 3x to the first power. I subtract 1 off of that. If I work that through, I end up with 3x to the 0 power. And x to the 0 power is equal to 1. So the derivative of 3x plus 4 is equal to 3. Let's make this a little more complicated and go to higher level exponents. I have y is equal to 1/2 x squared minus 6x plus 24. Again, we know that the first derivative, the derivative of a constant is equal to 0, so this is going to be equal to 0. So all we're really going to be concerned with is this first part of the function where y is equal to 1/2 x squared minus 6x. Again, we go through that same process. We multiply. When we take the first derivative, we take the exponent and multiply it in front of the function. Then we subtract 1 off of that exponent. We do the same thing for 6x. This is 6x to the first power, so we multiply by 1. And then we have 1 minus 1 as the exponent. So you can see that there. I just took the 2, multiplied it in front. So I have 2 multiplied by 1/2 x, and then it's squared minus 1. So we have 2 minus 1. We do the same thing for this part of the function, minus 6x. We multiply by the exponent, which is 1 here. So we have 1 multiplied by 6x, and this is 1 minus 1. Remember, this is 6x to the first power, so we're subtracting 1 off of that exponent. So if we multiply through, we end up with 2 times 1/2 x, which just gives us x. So we have x squared minus 1, which is 1. We do the same thing for 6x. We multiply by 1 at the beginning. So we have 6x to the 0 power. So we have 1 multiplied by 6, which gives us our 6x. And the power is 1 minus 1 is equal to 0. X to the first power is equal to 1. And we drop the 1 off of here. So the derivative of y is equal to 1/2 x squared minus 6x plus 24 is equal to x minus 6. Make sure you're comfortable with this, taking that derivative, because we're going to use this a number of times through the course. And if you have difficulties with this, you're going to really struggle with a good portion of the material that we're covering in the course.